Hi, Assalamu alaikum. My name is Khalid Sujon. I'm a student of software engineering. And today I'm going to talk about my FYP presentation. Basically, it was a fantastic journey for me. So without any further delay, I'm going to start my presentation. So first of all, I want to give thanks to my honorable supervisor, Dr. Ruhayanti Binti Hassan. Without her constant support, it wouldn't be possible for me to complete the whole thing. So thank you very much. And now I want to share my slide here for my presentation so that it can be easy for me. So let's go through my slide. Okay. So here, uh, first of all, I want to talk about the title of my fyp-1. Basically, the title of my thesis is Machine Learning Algorithm to Predict Student Performance in Higher Education Institute, right? And then I have my abstract here. So in abstract, I try to focus on uh, the background of the study and the overall things that we are going to implement here. Basically, we are working with a very popular, two popular algorithm. First one, logistic regression and random forest as well. As we are going to predict the student grade in this time, the most important thing is data set. So we are using the data set, the size of the data set is around 410 students. And I have collected the data set now with the help of my supervisor, and the data set contains the record of students who have taken AI course, right? So these data sets contains their test marks, assignments marks, and all. So I have some vital features of my data set as well. So my goal is that, first of all, I will predict, I will pre-process the data set, and I will train my model based on the training data set. And not only that, after that I will notice the accuracy level, and if I see any unwanted situation, then for example overfitting, on that time I will uh, further study about that. That's the thing. And not only that, for to overcome any unwanted situation like overfitting, we will mostly focus on data level solution. To do that, we are going to propose smooth. We will apply smooth and feature selection as well, right? Okay. So first of all, I will talk about my research outline. In my research outline, first of all, I will talk about the basic introduction of my FYP-1. Not only that, on top of that, I will talk about problem statement, objective, scope, literature review, research framework, confusion matrix, which will provide me in general idea for my model, and then flowchart, data preparation, model training, performance analysis, and future direction as well for my FYP2. And finally, I will reach at the conclusion. So let's go through the introduction. So what is happening now today? Traditionally, what we are doing, educational institution have relied on conventional grading system, right? And data management method. However, our study aims to revolutionize the process by leveraging predictive analysis. For example, we will employ logistic regression and random forest. We strive not only to accurately predict the student grade, but also to explore the potential impact of data-driven decision-making on higher education institute. We will use data to take the decision, right? We address the challenges. That is very important. We address the challenges of imbalanced data set by incorporating synthetic minority oversampling technique. In short, we will call it SMOOT. And not only that, we will apply feature selection to enhance the accuracy of our machine learning model or predictive model. And then I want to talk about the problem statement. because the solution will come from the problem. So I have decided to take two problems. First problem is outdated evaluation system nowadays we are using. The current evaluation system relies on traditional characteristics like learning activities and socioeconomic positions provide inadequate to accurately predicting student performance that can go wrong, right? The urgent need for improvement prompts the exploration of advanced technique like logistic regression and random forest to enhance predict accurately. And then problem statement two that will be defined as emerging technologies gap, right? As predictive analytics gains popularity in higher education or current evaluation method struggle to keep traditional approaches, right? Traditional approaches uh, rooted in learning activities and socioeconomic factors fall short in predicting academic success. So to bridge this gap requires leveraging machine learning algorithms such as LR and RF2 to provide educators with academic insights for informed decision making and effective support. Now, most important thing, what are going to be our objective? So first objective, we will compare two most popular machine learning algorithm. First one, logistic regression and random forest. Okay, then of course we will do some data processing method, and second objective will enhance predictive models. Let's say we are facing any problem when we were comparing our algorithm. So we will focus on data level solution. At that time, we will apply smooth, okay, and then we will apply feature selection as well. Not only that, to evaluate our predictive analysis, we will focus on some sort of evaluation metrics, for example, accuracy, precision, recall, F1 score, ROC curve, and all. That's the thing, that's our objective. And then we're going to talk about our scopes. First scope will be data collection, which is the most crucial part in any research, right? So we are collecting the data from 410 students, as I told you earlier, enrolled in AI course of UTM. The data set supervised by our advisor includes key features like the dataset will contain student ID, quiz marks, midterm marks, various assignments, and exam marks. This comprehensive dataset will serve as the foundation for our predictive analysis. So I got the data with those marks, but in the phase of data processing, what I did, I calculated the total marks for all those students, and then in Excel sheet, by using grade formula, I have executed all the grades for particular student. And finally, I have enrolled them in to 5 categories. For example, excellent, exceptional, good, and all. And then second scope is algorithm implementation. As I told you earlier, that we are going to implement two popular machine learning algorithm. One is random forest and logistic regression. And finally, we will focus on predictive analytics impact, how this predictive analysis can have a beautiful insight, can have a beautiful impact in our higher education institute. That's our scope. So in our whole research, we have conducted a beautiful existence study or literature review. Existence study proposed random forest as a superior predictor of student grades compared to logistic regression. However, it's vital to acknowledge performance variation based on data set and features. For example, right now I'm working with this two algorithm, but my data set is totally different from anybody because I am working with a real-time data that has been collected from UTM. And uh, however, it's vital to acknowledge performance given our focus on imbalanced data set. Both logistic regression and random forest emerge as suitable choices. Our decision aligns with data analysis and corroborated findings, positioning us to explore their efficiency in predicting student growth. Now, I want to give you a short overview about my research framework. Okay. So my research framework will contain around 4 phases. So in phase 1, what I will do, I will do data preparation. So as I told you earlier, I will work with the data set of AI course. So I will collect the data sets. Then I will do the data extraction. Okay. So my data features will be student ID, project marks, total marks, and so on. After that, in phase 2, I will do some data processing. For example, I will categorize them, okay, into 5 categories and all. And if I will observe my data set, is it balanced or imbalanced. If I notice any imbalance, then I will focus, I will apply smooth, and I will do feature selection as well. After that, I will compare those two machine learning algorithms, the accuracy of those two machine learning algorithms, which is random forest and logistic regression, right? By evaluating them. And after that, I will splitting the data, right? That our ratio will be 80/20. And then I will compare and select the best predictive model. I will notice which model is performing very well to predict student grade. And finally, we will visualize the data. Okay. So here, then I have created a confusion matrix. So I want to talk a little bit about that. So by using confusion matrix, we can get a beautiful and better understanding about our model's accuracy. So here, this table basically represent my confusion matrix, and this is my flow of task. First of all, we will import the data set, and then after that, we will perform the data pre-processing basically. Then we can directly go to classifier selection. For example, after my data pre-processing, I can run the logistic regression and random forest, right? That I have done in my FYP2. But when I will do my FYP2 on the time, I will apply smooth and feature selection for further study. And then predictive analysis, then I will split the data, and then I will notice and I will record all the evaluation matrices, including accuracy, precision, recall, and F1 matrix as well. Now, let's go through my implementation. As I told you earlier that our data has been collected. Now, I will go through the data preparation. So first of all, I will import the data, right? I have imported the data here. Okay, by first of all, let me tell you something. I have to import so many libraries of pandas, right? Now I have imported the data here. Then I have executed the class distribution. Okay, so if I notice here, the class distribution, as I told you earlier, that we have 5 categories. First one is distinction that contains 273 instances. Then we have pass that contains around 77 instances, and excellent 41, and so on, right? So that's the thing about our class distribution. And then I have used here level encoder, right? To encode our categorical value, because in our grade we have A plus, B plus, and all. So I want to encode them. So there are 2 methods to encode. One is one-hot encoder and level encoder. So we are using level encoder because it's a categorical value. Okay. Then from scikit, what we are doing here, we are splitting the data set basically into training and testing, and the ratio will be 20/80. Okay, so we are splitting the data set here, and then we are standardizing the data here so that our machine learning model can run this accurately. And after completing our data pre-processing section, we will dive into logistic model training. Remember, in our workflow, we have showed that after data pre-processing, we will focus on model training. So in our model training, we will focus on 2 models. First of all, we have worked with logistic regression, right? From scikit-learn, we have imported logistic regression libraries. So after that, we have trained random forest model as well. And then we have check the performance analysis. First of all, we have executed the accuracy, right? So in accuracy, we notice that the accuracy of the model is around 100%. So yeah, we know that sounds very good, but we have to be very careful about the data overfitting or model overfitting and all, and about the balanced data set as well. And then if we look at the evaluation matrix, all the evaluation matrices, for example, precision, recall, F1 score, and support, everything is 100%. So I think this is very good that we are noticing 100% accuracy, but we are very careful about data imbalances and data overfitting as well. So now let me tell you something about my future direction after this whole study, because I have already implemented one particular thing. So in my future direction, I want to say that in our primary research, we noticed that the accuracy for all the evaluation metrics are 100%. That means one, recall, accuracy, precision, and F1 score, everything is 100% in all test classes. Although these findings are really beautiful and encouraging and smooth, but we will examine more to check overfitting to resolve any potential imbalances. Whether do we have overfitting with this model and all. For this, we will use data balancing technique like synthetic minority oversampling technique. In short, we will call it smooth. This will ensure that the model is flexible for any kind of data sets. And not only that, to solve this concern, our plan for the second phase of our FYP2, right, in final year project 2, that will involve some sort of strategies, like we will focus on data balancing technique, feature selection, and data set splitting. For example, we will split the data set into different ratios, 20/80, 25/75, 36, 40/60, and so on. And then we will examine all the study. So that's the thing. In conclusion to sum up that, basically, we have run our model for initial result. We run logistic regression and random forest to predict the student grade. Not only that, we have split the dataset in training and testing dataset in ratio that was 20/80. So for further study, further approach for our FYP2, where we will explore more about our those two model. We will explore the data overfitting, and we will use oversampling method like small tools. Thank you very much for your outstanding attention, and thank you very much for your patience sharing. Assalamu alaikum wa rahmatullahi wa barakatuh.